Let's take a look at an example of finding the equation of the tangent line to a curve for a square root function, in this case f of x equals the square root of 2x, at the point 8, 4. Now, as we get started, we need to note that the tangent line to a curve is a line that touches the curve at a single point. So if we look at this graph here, we can see our square root of 2x function above the x-axis. And if we were to zoom in closer and closer to that point 8,4, we would see that this line in blue only touches the curve in black at that single point. And the slope of this tangent line is the derivative of the function f of x equals the square root of 2x. So our task here is to find the equation of that tangent line. So as I mentioned, this derivative can be thought of as the slope of the tangent line of f of x at a. So using the equation of a line, we'll use y equals our slope of our tangent line at the specified point, x minus our known x value plus our known y value. So there's the equation of the tangent line. And so in this particular case, we do know our x value and our y value. We know that x naught is going to be 8. And we know that y naught is going to be 4. The piece of information that we're missing is this slope of the tangent line, which we will be able to find by finding the derivative of our function at a. Keep in mind a is our x coordinate, so a is equal to 8. So the slope of our tangent line is going to be f prime at 8, which is equal to the limit as delta x approaches 0 of f of 8 plus delta x minus f of 8 all over delta x. So this is the limit as delta x approaches 0. Replacing x in our function with 8 plus delta x, we'll have the square root of 2 times 8 plus delta x minus f of 8. Well, we really already know f of 8. If a is 8, then f of 8 is the corresponding y value. So that has to be 4 over delta x. Now, if I didn't already have the y coordinate that went with 8, I could easily have found it out by finding the square root of 2 times 8, which is the square root of 16, which would have been 4. Okay, continuing on, we have the limit as delta x approaches 0 of the square root of 16 plus 2 delta x minus 4 over delta x. Now, at this point, we're going to have to use some algebra to rewrite this function in an equivalent form that allows us to think about how the function behaves as delta x goes to 0. In its current form, with this delta x in the denominator, we cannot do that. So what we're going to do is we're going to use the conjugate of our numerator to help us accomplish this. So the conjugate of our numerator is 16 plus 2 delta x plus 4. And then in the denominator we'll have, that's too big, 16 plus 2 delta x plus 4. Okay, so now we have the limit as delta x approaches 0. My denominator is delta x times the quantity 16 plus 2 delta x plus 4. And using the distributive property in the numerator, square root of 16 plus 2 delta x times square root of 16 plus 2 delta x gives me 16 plus 2 delta x. Doing my outer terms, I will have 4 plus 4 times 16 plus 2 delta x. Doing my inner terms, I'll have minus 4 times 16 plus 2 delta x. And doing my last terms in each, I get negative 4 times 4, so that's minus 16. Now, looking to simplify within our numerator, I've got a 16 plus stuff and then this minus 16. So these two 16s will sum to 0. I've got a plus 4 square root of 16 plus 2 delta x and a minus 4 times square root of 16 plus 2 delta x. So those two terms will subtract out or add to 0. Now, really the only thing left in our numerator is the 2 delta x. So limit as delta x goes to 0. Our numerator we have 2 times delta x. And in our denominator we've got delta x times square root of 16 plus 2 delta x plus 4. And now I have a factor of delta x in both numerator and denominator. So those will divide out. And note that this is now eliminating the issue of a 0 in the denominator. So we have the limit as delta x approaches 0 of 2 over the square root of 16 plus 2 delta x plus 4. And at this point, I'm ready to consider how this function behaves as delta x goes to 0. So as delta x goes to 0, my numerator goes to 2. And as delta x goes to 0, my denominator, inside the square root, I'll have 16 plus 2 times 0, and then plus 4, which is going to give us 2 over the square root of 16 plus 2 times 0. That's just square root of 16. So that's 4 plus 4, which is 2 over 8, or 1/4. So our slope of our tangent line is at x equals 8 is 1/4. So now we can go ahead and write the equation of our tangent line. And in this case, our tangent line is y equals 1/4 times x minus 8 plus 4. And it's perfectly fine in that form, or we could rewrite it in slope-intercept form. So y equals 1/4 x. 1/4 times 8 is 2, so minus 2 plus 4, or y equals 1/4 x plus 2. So either of these forms are perfectly acceptable. And then let's return to the graph we saw. Now, because I had provided the graph of the tangent line along with the curve, you could have found the equation of the tangent line without the calculus. However, you would have to have known what the tangent line graph looked like, and generally you don't know that ahead of time. So do notice that we do have y equals 1/4 x plus 2. That's what we found. 1/4 x plus 2. We can see that our y-intercept is here at 0, 2. And we can see that the slope of this line, if I go from the y-intercept to the point we were interested in, our vertical change is 2, and our horizontal change is 8. And so the slope, which is vertical change over horizontal change, 2/8, or 1/4. I hope this helps.